The Manchester Ship Canal, undertaking the waterway revolution setting the stage in the late 19th century, Manchester faced a pivotal moment in its industrial rise. The city was thriving, propelled by the textile industry, yet it lacked a shipping route to the sea. Located about 35 miles from the nearest coastal port in Liverpool, the challenge was clear: how to bridge a flourishing inland city with the global maritime network. An ambitious engineering project would be needed to transform Manchester from a landlocked entity into a notable port. This led to the conception of the Manchester Ship Canal, a monumental undertaking that would facilitate the transport of goods and highlight human ingenuity and engineering prowess against formidable obstacles. The engineering challenge, building a navigable waterway from Manchester to the sea, was a daunting task. Engineers faced challenges related to topography, hydrology, and the constraints imposed by natural waterways. The landscape included hills, valleys, and waterways that required innovative excavation and construction methods. The canal's design called for it to traverse diverse terrain, weave around communities, and overcome significant elevation changes. Creating a canal deep enough for large vessels meant addressing the geology of rock and soil types. These challenges presented numerous constraints, from sourcing materials and funding equipment to managing competing industrial demands that jeopardized the project before it began. Laying the foundation, designs and decisions. The idea for the canal emerged from early proposals by figures like Daniel Adamson and the Manchester Ship Canal Company, founded in 1885. Adamson advocated for a reliable shipping route and helped secure support and financing for the project. The chosen design featured a 35-mile-long waterway with locks and docks to accommodate ocean-going vessels. This required coordination with existing shipping routes like the Mersey River. Initial designs underwent revisions, emphasizing the need for a minimum depth of 27 feet and a width of 120 feet for the largest ships of the era. Managing the elevation difference between the canal and the sea dictated the placement and construction of locks, crucial for navigating the canal's height changes. Step by step, the construction began in 1887 and lasted nearly a decade, employing thousands of laborers. The initial focus was on excavation and earth removal. Excavation innovations included steam-powered excavators and hydraulic dredging equipment, dramatically enhancing efficiency. Another significant aspect was designing canal walls with slipforms and reinforced concrete to prevent erosion and flooding. Lock design incorporated chambers for multiple vessels, streamlining operations with gravity-fed systems and pumps managing elevation changes exceeding 40 feet. Navigational aids like lighthouses and markers were also integral to ensure safe passage along the new waterway. Obstacles faced, difficulties and breakthroughs. The project encountered notable challenges, including environmental concerns about ecosystem disruptions spurred community opposition. Engineers implemented sustainable practices to mitigate long-term damage. Financial difficulties arose as initial cost estimates soared, leading to public appeals for funding. Securing investments became crucial. Unforeseen geological conditions complicated progress, necessitating redesigns and delays due to unpredictable rock strata. By the late 1890s, collaboration and innovative techniques helped overcome these hurdles. The grand finale, opening the canal in January 1894, the Manchester Ship Canal was officially opened after 7 years of labor. This marked the dawn of a new era for Manchester, transforming its socio-economic landscape. Industries regained momentum as goods flowed efficiently between Manchester and global markets, solidifying the city's status as an economic powerhouse. The aftermath and real-world impact. The canal's impact extended beyond commercial gains, catalyzing urban renewal and the growth of industries like shipbuilding and manufacturing. It became vital for transport chains involving imports and exports, solidifying Manchester's role as an inland port. Innovations from the canal's construction influenced numerous global projects. Techniques in excavation and hydrodynamic management set precedents for modern canal building. However, challenges remain, including sedimentation and water management, necessitating periodic dredging to keep the waterway navigable. Reflective closing. A legacy of ingenuity, the Manchester Ship Canal embodies bold engineering amidst daunting challenges. It illustrates the interplay of urban needs with innovative design, reshaping landscapes and economies. More than just a transportation route, it highlights humanity's ability to adapt to natural constraints with creativity and foresight. The canal's narrative offers insights into collaboration, sustainability, and balancing industrial growth with environmental care, reminding us that engineering shapes society profoundly. Through this grand endeavor, Manchester transformed and stands as a testament to enduring human innovation.